Without further ado, I'd like to introduce two colleagues of mine and dear friends. They're going to talk about something really awesome, FileCry, the new age of XXE. So please get a warm round of applause for Sharon Wan and Sergey Gorgobati. Thank you so much.
Hello, everybody. We hope not to bore you on the last talk. So we'll show you some 0 days. We'll show you some cool demos. But first, let me introduce myself. Sergey Gorgobati, security engineer at Salesforce. I work on mobile and web apps. And my colleague.
Yeah, my name is Sharan. And both Angelo, Sergey, and I, and a bunch of colleagues are sitting here. We're all working for Salesforce. And my research interests are web application security, browser security, and a bunch of other random stuff. So we'll make it interesting. We know we're the only talk that stands between you and the parties. But we're going to make it as interesting as possible. So stay tuned.
All right. So what are we talking about? We're talking about XML, right? So XML is an interesting animal. It has a bunch of cool features. It allows you to embed the doc type. And when you embed the doc type, you can specify an entity, a general or parameter entity. And entity essentially is just a symbolic link. Symbolic link to a file or some data, anything that can be stored outside of the current document. And I really like this quote W3C put together, that all external entities are well formed by definition. Let's look into that. So here's a typical XXE 101. This was taken from the black hat of last year's talk. And essentially, this is an example of how to do XML external entity expansion. That's what the XXE stands for. So let's take a look. We have an entity called XXE. And it basically links to XXE password. And when XML parser looks at this, it tries to resolve and tries to fetch the XXE password and see what's inside of it. And of course, there's no XML there, so something will happen. All right, so this is not a new problem. We've talked, there's a talk this morning that was about XXE, and there are a bunch of talks from last year. So not really a new thing, but why are we still here? What's this talk about? So we're going to talk about, the problem that not only your applications that you use XML parsers and you fix them, but also the applications that you run on and the applications like browsers that you use to look at your web apps are also problematic and vulnerable. All right, so with this, I'm not going to drag too long. I'm just going to show you. So let's see. I was working on a simple web app that does nothing but pretty much takes a file, an XML file, you upload it, and it does a pretty print. Okay? So let's say I take a simple file, I upload it, and this is a work in progress, just a demo. So then I decided, well, hey, XMLs are problematic. Maybe I should look into defending against external entities. So I used the XML from last year's Black Hat talk, and I just uploaded it, and boom. What do you see? It's my XXE password. Okay, this is not good. All right, so I decided, well, let's go fix it in the code. Let's go look at my basically XML parsing and where I create the factory. You see, I'm just creating a factory. So let's just make sure that we secure it. Okay, so how do I secure this thing? So I was like, oh, hey, I remember that OWASP had some recommendations. And when we look at the Java section, okay, you have document builder factory, you have Xerxes. Oh, okay, XML input factory, the one that I'm using. It says, turn DTD off. Well, that's not what I need. I really need to make it work, because I don't want it to throw an exception when I use DTD. So I kept looking, and so we basically found a way to turn off external entities specifically. All right, so let's try this. We're going to turn off external entities, save, stop, restart the server. Okay. We're still up. Or so. All right, and upload the same factory and see what happens. What's the problem? Looks like my XXE password is still resolved. Even after I set the JDK, please don't touch my files and don't touch any external entities, it still resolved it. So this looks like a problem, and Java is telling you how to do it, but it's not working. So we kept looking and decided, well, hey, there's another feature in XML parsers called resolvers, and you can pass in your own resolver. So let's try to do this too. So we have a factory, set the XML resolver, and create a new XML resolver. And this basically creates a, every time that XML is asking us to resolve something, it just returns null. Okay, so this should totally work, right? XML is not supposed to resolve. Like I'm returning it to null. Let's try again. Coming back, refresh, try again, upload, still the same problem. So what's going on? Looks like we have an XML parser that has a feature, is supporting external entities, and I went to look in the documentation, and its default value is actually unspecified. That was interesting. So with the unspecified one, I decided to, well, if you set the proper feature to false, this should really not work. But as you just saw, it doesn't work for the malicious case where you have external entity that expands inside another entity and makes it throw an exception. But for normal files, it worked. So this made me really wary of working with XML in Java. Especially if you take into account that you set Java don't resolve and it resolves. So what is the effect? SOAP API, SAML, SSO, XML RPC, all of those use XML that you can pass doc type, that you can pass external entities, and even if you're set on your server, in JDK, hey, do not resolve external entities, still works. So we of course thought, well, this is a problem. So we contacted Oracle, and Oracle said, yeah, this is a 0-day. We're going to fix it. And so essentially, like all of the JDK was affected, like every single version. This is cool. So resolvers, I thought, well, passing null, should have been really fixing the problem. But turns out that the Eclipse auto-generated stub is not super helpful. What you really should do, and is slightly counterintuitive, you need to return a completely new input source. That would actually fix it. All right, so now you have a web server running an old version of Java. A relatively old. 7 update 65. It's not really that old. So if you have this service running, and what you can do, you can steal some data, but how do you get it? You can get it using a couple of ways. You can use the XML printing of the errors that I showed to you, or actually you can use the DNS out of bound that was talked about in Black Hat 2013. But DNS has kind of quite a few disadvantages. There's a limit on the size, there's some characters that it can support, so we decided we're going to just focus on the exceptions. Okay, so if you look at the exception that is created if you try to resolve a file by an XML that doesn't really exist, like XXE passwords. What happens is that underneath, it's a nested exception that tells you that, hey, I just couldn't understand what is the thing that you're trying to look at. Okay, so that means that we really need to do is just cause exceptions. And if we're trying to read like file system, with XXE content, then you can just pass, jar //XXE, and that's it. You get to read it. So when you got to that point, you're essentially looking at the contents of the file system that is exposed to the user as an exception. So you call a SAML API or like SOAP API, and you get back an exception, and it gives you the content of the server's file system. That's pretty cool. All right, so this is how it looks. All right, so I thought this was interesting. With OWASP that covers only 3 types of parsers, stacks, and it covers the stacks parsers and 2 types of xerces. The recommendations don't cover a whole lot more JDK parsers. On top of that, you also have popular parsers that are available out there. And mind you, those parsers are actually using, let's say Apache and OpenSAML. They use XML parser underneath the hood, but they don't expose any way to configure it. So then you're using these features and you can't secure them at all. All right, so what do we have left? At this point, where we have some features that you can turn off, and so you have to just at least try to fix whatever code you own. So with that, you're trying to say, well, what can we do? We can disable external entities, like you saw me try, and you can disable DTD or support altogether, like OWASP recommends, but that may not be what you want because you may need DTD. So then you can actually try to turn off also duck type fetching. But the problem is not the mitigations. The problem is the parsers themselves. One parser is not like the other. There are a bunch of parsers that you can turn the features off, and that's cool. And if they work, they work. And you can also try to set in resolver, like I did and failed. And there are quite some parsers like that. But there is one parser that I like in particularly. Unmarshaled, it doesn't support any features. So you can't set anything whatsoever. So if you use it anywhere, you're pretty much using it at your own risk. In order to fix unmarshaled, you actually have to create yet another parser to parse your document, and then you have to turn off, of course, all the external entity fetching. And then you create a document. You pass the document to unmarshaled. If everything fails, you just have to pick an XML parser that has a way to turn off protocol and disable protocols altogether. So by using the set property XML constant access external DTD and setting it to empty string, that means you're limiting the whitelist of allowed protocols like HTTP, FTP. And there's a link of how to do it. But this is all cool. We talked about a lot of server apps and use them XML. Not many apps use that. We kind of need a bigger target. So with that, I'm going to pass to my colleague Sharon.
All right. Thanks, Sergey. So if you can switch to my screen. OK, here we go. Thank you. OK, like Sergey said, the Java parsers are complicated, and they all have different ways that might work to support disable different things. And we need a bigger target. And let me give another punch of Steve Ballmer. So what are we targeting? We talk about XXEs, but we talk about it in the context of web applications. We thought about the way as to exploit it as using a malicious XML to attack a server in order to get the content of the server out. So say in a scenario you want to attack a server, that works. But what about other cases? What about you want to attack an individual user? We want to attack billions of users. We want to make the biggest impact to different vulnerable products. And we try to think about what are the products that are used by billions of users that are parsing XMLs. And the answer is not that complicated. It's browsers. So we didn't go directly into exploiting browsers. We look into the history of browser-based XXEs. If you take a look at the screen, Chrome and Firefox, Chrome and Safari, they were vulnerable before 2012. because they were using the vulnerable version of libxml2, but that was fixed in 2012, and they're fine afterwards. Same thing to Firefox. Also used a different library, but also fixed in the same year. You can see the CVE actually is pretty much close, so they're actually reporting at the same time. IE, on the other hand, is a different beast. They actually fixed the parser in 2006, but their fix is to coming up with a new parser without fixing the original one. So the new parser is called V6 or version 6, and the original version 3 is still vulnerable. So our question is whether we can trigger the vulnerability somewhere in version 3. So we checked out, and version 3 is only linked with IE6. So we figured, nobody's using IE6. Well, we hope nobody's using IE6, otherwise we'll have bigger problems. And how can we exploit the issue while we're using newer version of IEs, right? Because we don't want to just targeting IE6. That's like targeting a disabled. But we want to go with newer version like IE11, where people are actually using. So Quarks mode, I think maybe a lot of you already heard of this. Quarks mode is an interesting feature in IE that you can let the browser to run in the older versions of the IE to maintain compatibility. Say you have a new website and you have an old website, it's not working with IE11 or IE10, you want it to work with IE7, IE8, or even IE6. So IE gives you this convenient feature to roll your browser back to 10 years ago with the security of 10 years ago as well. So attacker can conveniently set the HTML page, the malicious HTML page, with a meta tag, say, going to render the content IE6, or with other types of things like through HTTP response, or through a doc type. Many ways you can set the Quarks mode. But the point takeaway is that you can enforce IE to force it to run in the mode that was only used like 10 years ago, the vulnerable mode. And we'll see the proof here. You see it through Process Explorer, MS XML 3.0, right here on the screen. It's linked to IE11. This was the most recent version of IE11 before they fixed it. So that was interesting. So obviously, the vulnerable version of MS XML3 was linked to IE. So there must be a way to exploit it. And before we go into the way, very quick 101 on how to parse XML in JavaScript. In IE6, you just create an ActiveX object and load it. In other browsers or other version of IE, you use the standard DOM parser. So how do we exploit the vulnerable version of MS XML3 in the newer version of IE? And our goal is to do two things. To break same origin policy completely, where you can read content across domains, and to exfiltrate data on the disk. And these are the two goals we want to achieve with XXE. So very simple payload. Here's the first trial we were doing, although it didn't work, but kind of lead the way of the second one. So if you see the one victim.com marked in red, that's the website we're going to exfiltrate. So very simple. Just point an external entity to victim.com and load the content of that page into your malicious page. So let's see whether that works and why that didn't work. So I have a page right here. Let me zoom in. It's basically the same XML. And we're just trying to exfiltrate the data from google.com while we're on attackerdomain.com, right? So we're trying to exfiltrate data across different domains. If this succeeds, we break the same origin policy. So whatever we exfiltrate is going to be in the box right here. So we click parse the malicious XML. Nothing happens. So that was weird. It's supposed to work, right? Because MS XML3 was used to parse this XML and should be vulnerable to XXE. But why it didn't happen? So let's try that again with the console open, see whether there's an exception thrown or anything. Parse again. Access is denied. And it's denied on the line where we are trying to parse the library using the load XML. So that's interesting, because we thought it should succeed because it's using the vulnerable library. So why it didn't work? Let me show you another example of exactly why it did not work. This is the exact same example with the loot or the target pointing to a document on the same origin. So remember, we are on the origin of attacker.com. We're also trying to exfiltrate the data on attacker.com. So once I click on parse, we got a file out. So you can probably already guess what is going on. The thing that's going on is same origin policy is blocking us. So how do we bypass same origin policies? Well, I already gave you a hint, although that's not the way we work for us. But we look at the CVEs in the past of how same origin policies bypassed in IE, in Firefox, in Chrome, in different engines of renderers of browsers. And SVG is one of them. Set timeout is one of them. Time of check, time of use. And the other one is redirects. So I'm marking it red. You probably already know this works for us. So how it works is basically is trying to go to retrieve a content to the target website, but instead of going there directly, we go to a redirector on the same origin to redirect to the second origin. So if you take a look at the example here, the only thing that has changed is the website, instead of going to victim.com directly, it's going to attacker.com with a redirector, assuming the page is hosted also on attacker.com. And yes, we own that domain. So let's take a look at how we can actually use the example to exploit things. So we're going to show you two demos. One is to read a secret Google Doc document of a victim. The other one is to read arbitrary disk content of the victim. Both of them do not need user interaction. Only thing user needs to do is to click on the link and he's compromised. Let's see how that is done. So let me paint you a story. Let's say the victim is a boss or manager in a company, and he has a secret doc on the Google Drive showing the salaries of different employees underneath him. And the attacker on the left-hand side in Chrome is an employee that's trying to access the document. If you can see that, the access is denied. Right? So the attacker's goal is to exfiltrate this document through just a link. So let's see how it can do that. And remember, the victim is an IE. So now the boss checks his email, and he got an email in the morning or in the afternoon. It says, click me. Pretty good. The boss likes to click on links. So just click on the link, go there. Everything's all right. Nothing can go wrong. What can go wrong, right? And let's refresh the page on the attacker side. Every single thing in your document. And I will explain. Thank you. I will explain how it happens in a slow motion afterwards. But this is the first demo, just to exfiltrate content with a link click. Okay, second demo, same thing. The boss also have a habit of keeping his username and password, all of the secret information in a file, XXE file, so that they can remember it. He doesn't use LastPass, password manager, or whatever. He doesn't trust us. This is pretty scary. Just put it in a TXT file on his own drive. And our goal is to get that file just with a link click. So remember the content. A bunch of username and password. Of course, those are not real. You can try, don't work. But you see, those are the thing we're trying to exfiltrate. Okay, same thing. The boss wake up in the morning and go to check his email, got another link. Without realizing it was pawned yesterday, he clicked on the second link, and we'll see what happens afterwards. He's still going to Google. Nothing happens. I don't think anything happened. But on the attacker side, when he reloads the page, every single thing in that file is exfiltrated. So both of the attack was leveraging XXE, and I will demo how just one of them worked in a slow motion. And if you go back to the page, so this was basically just the page that without all the fancy redirects and Flash redirect to Google.com and everything, just a static page. And remember, what attacker needs is just one thing: the URL of the document. Say the attacker knows the URL of the document, And let's say the URL is right here. This is the URL. Remember, this is only a slow motion, and all of this can be just done automatically. The attacker doesn't have to ask users to type in a link or anything, just done in slow motion. So now you have the attacker has the link, and the victim clicks on the view, and everything is stolen cross-domain. And if you take a look at the inspect element of the page, there's only one interesting line you want to look at. Actually, two lines. I lied. Here. First line, create an XML parser. Second line, parse the XML. Done. You're pwned. And after that, you just want to get the content out. And the content is actually exfiltrated through a parse error. And I explain what is a parse error and why we're not using just XML DOM later on. But that's not important detail. So the important thing is that after just parsing the malicious XML, we can just successfully exfiltrate the external entities pointed by the XML and send it to the attacker's CNC server. And let's go back to the slides. So after seeing the demo, we of course reported the vulnerability to Microsoft, and they fix it in the library MS-XML 3.0. Actually fix it, not getting a V7 out. Actually fixing V3. But if you think about it, it wasn't IE that was vulnerable. IE actually was trying to protect it from being vulnerable. The library itself was the vulnerable one. And if you think about what are the other softwares or other frameworks or DLLs or binaries, EXEs that are using MS-XML 3.0 or linked to it, they were vulnerable too. Or if you didn't have the patch, they're still vulnerable. But they definitely were vulnerable too. And just to give a hint of the scale of the problem, MS-XML 3 was introduced in 2001, exactly 15 years ago. So I don't think it's a complicated exploit. I'm suspecting it's probably already being exploited in the wild. But that's just a ballpark guess. If you take a look at what are linked to MS-XML 3 directly, we have found just 46 binaries XMLs out of the box that are linked to MS-XML. Those are just linked directly. Indirectly, there are 187 binaries and DLLs that are linked towards with MS-XML 3.0. And those are just the libraries and XML and the binaries that are available by default on Windows. God knows how many third-party libraries are linked to MS-XML 3.0 that are still vulnerable. So it's a pretty big impact problem. But good that Microsoft fixed it and released a patch in April. So there are a few limitations about attack. One is whenever you're trying to exfiltrate the content, the XML parser assuming the external entity you're trying to exfiltrate does not contain some special characters or only conform to the XML grammars or rules. And special characters would contain open-close tags, percentage signs, null bytes, or stuff like that. So what it means in the web context that a lot of HTML pages are not vulnerable because they contain the open-close tags or HTML tags, anything. But wait a second, I just show you I can execute the Google Docs, right? Because that's just HTML page, definitely contains a bunch of tags that has open-close tags and everything. The first few hundred bytes are vulnerable because they will come out of as a parse error. So even though the page contains open-close tags, they trigger an error. The parse error contains first few hundred bytes, which is enough to exfiltrate the Google Doc contents, Google Doc name, and a lot of websites content. I think maybe Box was also vulnerable. Not Box itself, but the browser who's using Box. And JSON pages are vulnerable because they do not, most of them do not contain open close tags. They just contain the braces and stuff like that. Those are valid characters in XML. And binary files are usually not vulnerable because they usually contain null bytes. So things like registry files or Outlook backup files or even the browser cookie files. Those are binary files, SQLite databases, something like that. Those are not vulnerable. An interesting thing about IE's cookie files. IE cookie files are just plain text files. However, there's nice property that are there that we're not able to exploit. The file name are not guessable. And in our attack, we're not able to at least yet to enumerate the files in the file system. Only if you know the file name and the path, we can get a file out. You can still enumerate manually like brute forcing, but there's no way you can just get a direct listing automatically through XXE. So because IE randomized the file name of the cookie files, we weren't able to extract the cookie files of IE. But other files that you know have deterministic path or file name, you know the file you're going to extract, you have a targeted file, you can definitely leverage the vulnerability to completely extract it. And the attack only works on IE Windows 7 or below, but all IE versions are vulnerable. So Windows 8 and up are not vulnerable at all. But come on, who's using Windows 8 and up? So as a defenses, update to the most recent version of IE 11, or actually apply the system security update because it's update to a library. And also use Windows 8 and up, I guess. So conclusions. We have shown you the old days in both Java and IE, and it's a big problem. We think it should deserve more attention, especially like Sergey mentioned, services like SOAP, API, SAML, single sign-on, and a lot of those are XML parsing. And if you don't deal with XML seriously, they're going to ruin your servers, your users, your products. And other languages and products could potentially be vulnerable too. We didn't have the time to investigate into Ruby's or Python or all of the fancy new languages. So they might as well be vulnerable, but we don't know. And we also recommend XML parsers for the new libraries to be secure by default with those dangerous functions and functionalities turned off. So we also want to say a special thank you to a bunch of our colleagues, especially Hormaz and Jonathan, who spent a lot of time on the research as well. They did a killer talk yesterday on breaking SMB. So if you need to have a chance to check it out on the website. They should have the slides already. So that is all of the content, and I want to thank you for your attention. And please leave feedback if you enjoyed the talk, and we love to hear your feedback. And any questions, raise your hand or come talk to us afterwards. Is all welcome. Thank you.
There's a question?
Oh, yeah, go ahead.
Does this work? There we go.
Yeah, it works.
Hey, great job, guys. I just wondered on the MSXML stuff if you had tried the C data wrapping trick or the out-of-band URL tricks in order to get at HTML special characters instead of using the exceptions.
Good question. Good question. So we tried both C data wrapping and also mParsed external entity. And what's the other one?
Like the out-of-band attacks where you embed the data in the URL?
Yeah. We tried that too. None of them, unfortunately, worked. So yeah, good question.
All right, cool. Thank you.
Yep. Anyone else?
Thank you all.
Great. Thank you.